Lesson 6.3, functions. Our objective for this lesson is to be able to describe a situation as a relationship between a dependent variable and one or more independent variables. We're going to define a function as a relationship between two quantities where one quantity depends on the other. Now, it's also true that not all relationships between quantities are functions. To be a function, you have to have this property that for every input, there's exactly one output. But I feel like sometimes we get too focused on that part and forget the basic definition of a function and the purpose of a function, which is just to define this relationship between two quantities, where if we change the one quantity, then we want to know how that's going to affect the other quantity. All right, so these quantities, we're going to call them variables. Variables are quantities whose values can change. Their values change within the context of the function. And again, that change is what we're looking for. If we change one of the variables, how is that going to change the other variable? The two types of variables we're going to talk about are dependent variables and independent variables. The dependent variable is the output value of a function. So for example, if we have, let's say our paycheck, we're looking at how many hours we worked and how much we get paid per hour, and that's going to determine the size of our paycheck. The size of the paycheck is the dependent variable. It's the output, and it depends on the other variables. In this example, the other variables are the amount of hours we worked and our hourly wage. Those are the independent variables. So an independent variable is the input value or values of a function. You can have more than one input variable, but just one dependent variable. So for in our example, the hours that we worked and our hourly wage are independent variables, and they are going to, changing those variables is going to affect our dependent variable, which is the size of our paycheck. I want to very briefly talk about function notation. So function notation is this, that y is equal to f of x. And what we're saying here is that our dependent variable y is a function of our independent variable x. So y is our output. It's also known as our dependent variable. And then x is our input, and that's our independent variable. So if it helps you to remember which is the independent variable and which is the dependent variable, you can remember that x is our input, it's our independent variable, and it goes inside the parentheses. Now, often when we put something into function notation, we're not going to explicitly use our dependent variable. There's not going to be a y there. You're just going to say f of x equals and then describe the function. So for example, f of x equals 3x plus 2. We're saying that our function of x is 3x plus 2. And so if you put in, if you have your input or your independent variable, if you know that, you can plug that in for x, and then whatever you get is your output, which we understand to be our dependent variable. The instructions for our examples say, for each of the following statements, state whether two variables are related in a way that might be described by a function. If so, identify the independent and dependent variables and write a short statement that expresses a possible relationship between the variables. Our first statement is this: the total distance a car has traveled after various amounts of time during a road trip. So the first thing we need to do is determine whether there's a relationship between variables here that can be described as a function. And I think there are. There's distance and there's time. As the time changes, the distance is going to change. In other words, the longer we go on this trip, the more distance we're going to have traveled. So the time, the amount of time that we're spending, is affecting the amount of distance that we're traveling. The amount of time is going to determine how far we've gone. So our independent variable is going to be time. And our dependent variable is going to be distance. And then as far as the short statement of the relationship, we'll just say that the more time we spend on our road trip, the more distance we will have traveled. Our second statement is this one: the way the price of a new smartphone affects the number of people who buy it. So first, is this a function? Well, can we find two variables that are related to one another? And I think we can. Here, the price of the smartphone is going to be one of the variables, and that's going to affect the number of people who buy it. And what is that relationship? What's the independent variable? What's the dependent variable? Well, here we're told that the price of the phone is going to affect the number of people who buy it. So the price is the independent variable. I'm just going to call that X. So our independent variable X is going to be the price of the smartphone. And then our dependent variable, which we'll call Y, is going to be the number of people who buy it. And now how can we describe this relationship? Well, the higher the price, the fewer people are going to buy the smartphone. So that would be our description of the relationship between these two variables. The higher the price, the fewer people buy the smartphone. The last statement is this one: the list on your grocery store receipt giving prices of items you purchased. So the first question is this a function? Can we describe this as a relationship between two variables, where one variable, changing one variable changes the other? And I don't think we can. We've got prices, we've got the items that you purchased and then the prices of those items, but there's no obvious relationship between those two things, where if you change one, it will change the other. There might be if we said the relationship between the number of items we purchased and our total bill, that would be a function. But this statement isn't something that we can describe as a relationship between two variables where changing one is going to affect the other.